welcome to sunny Florida. My name is Eric Menges. I've been the plant ecologist at Archbold Biological Station for over 30 years. And here we are at Archbold Biological Station in a beautiful example of Florida scrub. So ecologists have known for a long time that plants of the Florida scrub are very good at resprouting after fire. These palmettos here and these oaks each have their own ways that they resprout and repopulate the area. We're standing in an area here that burned about 1 year ago. So we know this resprouting trait is very important to the recovery of this ecosystem. But I wanted to ask the question, what were the limits of fire intensity that might suppress resprouting and cause these plants to die? And I finished another project that looked at frequency of fire, and this project I'm going to talk about today looks at the temperatures of the fire, the heat of the fire. And what we did is we did over a dozen fires where we marked individual plants, and in addition we used these data loggers here which would measure the temperature of the fire every 2 seconds. There's a lead here, and we would bury the data logger itself at the base of the plant with these leads coming out, and we can measure temperatures. We can program this to measure temperatures every 2 seconds. And then we can look at the maximum temperature in the fire, and we can look at the amount of time that the temperature is elevated, called residence time. And those are the two variables we expected to affect the abilities of the plants to resprout and grow after fire. Well, what did we find from this project? When we crunched the numbers, we found that the maximum temperature that the fire reached did not affect resprouting percentages or growth. We also found that the residence time, the number of minutes there is a heat pulse, did not affect resprouting or growth. These plants here as a whole had over 90% survival with the fire, very comparable to what you would see without the fire. So they're very well adapted to resprouting after the fire. Our research did show differences among the species. So these palmettos here are particularly strong resprouters with high percentages surviving and really rapid growth compared to some of the oaks that take a little bit longer to reach, say, the size they were before the fire. So the implications of this are that fires can be as hot as you want and as frequent as you want, and you'll still get the resprouting of these oaks and palmettos and dominant shrubs, which frees the land managers to tailor fire to species that don't resprout, that are more sensitive to, for example, how often the burn is applied. Archbold land managers and scientists have been involved with fire for a long time. The first prescribed burns here were in the mid-1970s, and every year now the land managers and their crews burn hundreds of acres in different parts of this biological station. So you might be wondering how we accomplish the fire treatments. And I work with our land manager, Kevin Main, who was burning different areas in order to manage the property for conservation and for safety. And in those areas where I knew he was going to burn, then I could set up transects and look at the plants. The process of doing the prescribed burning takes a lot of people and a lot of planning, and it's very complex, but the result is a healthier ecosystem that's periodically burned. So when the land managers on burn day have to get ready for the fire, they gather people together and they have a briefing with what to expect and how to deal with different contingencies. And the prep before the fire may involve mowing the edges of the fire in order to be able to start the fire better and to control it, and cutting down snags that might provide long distance sparks that might create spots outside the burn unit. While the fire crew is involved with getting set up, the research crew is also going out to the site, programming those hobo data loggers and installing them, and then often helping with the fire. After the fire, then we return and pick up the data loggers and score the areas of whether they were burned or not in order to figure out the effects of the fire on resprouting. Interns get a great fire experience here at Archbold. They participate on prescribed burns, and it gives them a great background in fire behavior and fire effects, and then many of their independent research projects explicitly look at how aspects of fire affect the response of plant communities or the individual species that they're interested in. So there's a lot of different ways fire research could go here in the Florida scrub. One interesting thing to look at that hasn't been looked at very much is how the ability to resprout depends on carbon storage in plant roots and rhizomes. They store this material as starch, and probably the amount of starch that's stored is going to affect how vigorous the response is. Another thing that needs to be looked at is the interaction of ecological processes and animals in the vegetation recovery. And one thing we've noticed is that after fire, the resprouting shoots are grazed quite a bit more by mammals like deer than the shoots that are growing up in between fires. So there may be some interesting interactions to look at with fire and other organisms and other processes in the Florida scrub. We can also take advantage of new technologies to understand more about fire. Already at Archbold, we use drones to map the extent of fire and the intensity of fire across large landscapes. And this provides data that would just be too time-consuming to collect on the ground. And so a lot of the research at Archbold on fire and other kinds of research can be scaled up to the larger landscape using drone technology and other advances. Well, I appreciate you joining me here in Florida to look at fire in the Florida scrub, and I look forward to your questions.